Well, welcome everybody. I'm glad you can join us for this webinar, the Data Summary and Analysis. I invite you to look at certainly the whole webinar schedule. We have some great academic webinars and even commercial webinars that might be of interest to you. So I want to give you, before we get started, a little bit of an overview of what I want this hour to do, or what I want to show you. And I'm actually going to jump right to the end because I always want to make sure that you have lots of resources on our website that can help you get more from JMP. So I just want to point you to a couple of these, and then at the end I'll circle back and talk about them a little more. But I always like to mention the JMP Academic Community. This is a new community on our user community that's really set up for academics. So we have rooms for teachers, students, and resource center. So you can get to a lot of materials that way. I also want to point out another website, jmp.com/learn, which will take you to our learning library, which has a good deal of resources organized by topics. So if you're interested in correlation and regression, you can go to that area. And there'll be a number of different sections underneath here, each with one-page guides, so printable guides with directions, videos, tutorials. So certainly this isn't your only chance to learn about JMP, and I want to make sure you know about those resources that we have. All right, so with that, let me tell you what I want to talk with you for about the next hour. I wanted to cover a little bit of the JMP basics. So if you've never used JMP before, don't worry. I'll certainly step through some of the basics of the software. And I also like to do this section for those of you who have used JMP before, because there may be some important features that you haven't used yet. And certainly there were some that I didn't discover until a couple of years after I started using JMP. So I want to make sure you see these because they can really speed up the time it takes to do basic analysis and to really get the most out of your data. Next, we'll go through some summarization of data, and I want to, in particular, look through the Tabulate platform, which is an incredible way to make tables and to really summarize your data. And, sometimes that's a really important aspect of what we do. It's not always the final analysis you need to get to, but sometimes you need to summarize or even aggregate variables. And so Tabulate's a great platform for that. And then finally, we'll look at some more or less basic analysis. We'll use distribution, which will address one variable questions. So it could be a one variable chi-square test. It could be a one sample mean. We'll also look through fit y by x, which addresses bivariate questions. So this could be anything from a logistic regression to contingency analysis, correlation and regression, or even analysis of variance. So we'll get through those too. And then, of course, I'll leave time for question and answers. I'll probably even stop after each of these sections just so we can address anything before I move too far beyond the subject of your question. All right, so let's jump right in, and pun intended there. So what I'm going to do is open up a sample data set. So I'm using restaurant tips for a lot of my examples today. Now I'm using my journal here on the left. This is actually a piece of JMP. You can make your own journals under the File menu just by going to New Journal. And these are great ways to store analyses or to even give lectures like I'm doing here. But to get to this data file that I just got to, if you're not using my journal, which you probably aren't, you can get to it by going to the Help menu. And there's a whole section for sample data. And JMP comes with about 400 data sets. So if you are looking for a data set to play around with or even one for teaching with, you can go to the sample data index. And to find the exact data file I'm using, I would click the Open the Sample Data Directory link. And then I'll take you to a whole listing of these. And you could just scroll down and find restaurant tips. But the sample data index is great. It actually organizes by types of analyses the data sets are good for. So if you're trying to show exploratory modeling to a class, or if you want to explore that on your own, you can go to a particular section with data sets that make sense for those analyses. So I certainly invite you to look through that. All right, so now that I have my data set open, let's just take a quick second to look at the anatomy of the data table. So in JMP, data tables are the basic place where you put all your data, obviously. Unlike Excel or other software that lets you put other things in your data set, notice that mine just has data. I don't have things like equals average. We don't perform cell calculations. The data table is really here just to hold your data. And the basic rule is whatever unit of analysis you have or unit of sampling, that should be a single row. So in this case, our unit of sampling is a table. And for each table, we have different attributes we've collected data on. So bill amount, tip amount, whether the table used a credit card or not, the number of guests, the day of week, whom the server was for that table, and the tip percentage. So our different attributes are here as columns. And I want to make a note that if you need to adjust properties of columns, or if you'd like to set different things for them, the way you get to column properties, and this is important in JMP, just right-click a column and go to column info. And that is the basic place where you'll find, all the structure of your columns. And we'll come back to these two in a second, data type and modeling type. This is where you set your formatting. And this is also where you can set additional column properties. So everything from setting a column formula. So columns can take on formulas in JMP. Individual cells do not. So we can talk about column formulas, but other things too. If you want to leave yourself notes about the columns, perform list checks. So if you're entering data manually, value ordering and value labels. So these can all be set under column info. Now, before I close the column info, I do want to point out two things. So data type and modeling type. Because in JMP, our data tables are what are called structured data tables. They enforce certain rules about what data you enter in each column. Of course, each column should only represent one attribute, so we're not putting tip amounts in the bill amount column, of course. But notice that bill amount, tip amount, these are in dollars, so we've used the formatting, but they're also numeric, right? These are representative of a real scale, unlike something like credit card, which is really identifying categories in the environment. So in JMP, we identify these, and this is actually known as the modeling type in JMP. So notice for my bill amount column, this is listed as continuous. Let me actually click on this, and you can see we have different options. We could tell JMP we wanted to model this as ordinal or nominal. So JMP is going to assume that if we have numbers, it's representing a real scale. That's what we would call a continuous modeling type. But we can always change this to be something else, and I'll show you what consequences that has. JMP is actually pretty special in that it'll adhere to your modeling type, whatever you select, and it'll try to perform whatever operations or representations of your data make sense for that modeling type. And so we'll come back to that in just a minute. But I do want to point out that on the left-hand side, you also have a listing of your columns. And this is really useful when you have very, very wide data sets because you'll actually have a scrollable list of just the column names. And you'll also notice there's a little icon next to each column. So bill amount and tip amount, which are continuous, that is, we're modeling them as if they have a real scale. If I click on that little icon, I get another option for selecting that. So it's the same option, it's just we put it in multiple places. But if you look at credit card or day of week or server, right, those are really categories in the environment that we've measured. And so their little icon is this red histogram, and that is a nominal modeling type. Now again, this is something that JMP will pay attention to. When it produces analyses, it'll be important to make sure these modeling types are set correctly. And I'll just mention that as a default, when you bring in new data, JMP will assume anything that's a number is continuous, and anything that is characters is nominal. And this should make sense. There's no way that credit card has a real underlying scale. So it assumes something that is probably most of the time correct. But I will just caution you, if you enter something like gender as 1 or 0, which I see oftentimes in social psychological research, then JMP will assume that that is a continuous variable. 1s and 0s are numbers. JMP doesn't know that those are just categories. So that's a situation where you want to click on that variable and set it to be a nominal modeling type. All right, so now with the basic sort of structure of JMP, let's get to something I think is more interesting about JMP, which is how it's thinking about your data and your analysis. As this is a section I call just the mind of JMP. And I'm sure this comes from me being an experimental psychologist. I like to think about things in terms of how they think. And so the way JMP thinks about your data is actually a little different than other software. And I would say it's more organized around the process of analysis than the procedures of analysis. Now, in a lot of software, if you're going to run a particular analysis, you'll go to an Analyze menu and you'll get tons of cascading lists. So there may be a section for general linear model, and then under there you may select the multivariate analysis of variance. In JMP, it's not that way. JMP is built more around the process of digging through your data. And so it organizes the thousands and thousands of analyses that it can do in a slightly different way. And it's a way that's going to pay attention to the modeling types. Now notice that with an attention to modeling type, that circumscribes the area or the sort of domain of analyses that make sense. If you're using a continuous column, but say you're using 2 continuous columns, JMP knows you're not performing a chi-square test of independence, so it doesn't need to give you that option. So JMP is actually getting around the issue of displaying you thousands of analyses all at once by paying attention to what variables you'll be using in your analysis. And so that's how it's paying attention to the modeling type. Now, JMP also has what we would call a progressive interface. That is, it's exploring data, really, and as you create new analyses or new output, you're given the option to dig deeper. So there's no need to display every option all at once because options can unfold in front of you. And this produces what we'd call context-dependent output. And so let me actually wrap these all together and show you what I mean. I'm going to go to the Analyze menu and bring up the distribution platform. So distribution is all about one variable questions. So times when we're interested in single variables or attributes of single variables. Now, we don't have to limit ourselves to looking at just one at a time, although jump is going to analyze them one at a time. So I'm going to take two of these. I'm going to take tip amount and credit card, and I'm just going to click them into the Y role. So here we have them in Y. And I'm going to click OK. And I want you to notice what jump has done with our output. For tip amount, which is continuous, we told jump that it was continuous. It's given me a proper histogram, and it's given me quantiles and summary statistics. It's calculated actual summary statistics for this variable. But for credit card, which is a nominal column, notice that jump hasn't done that. Jump knows we're not going to get a sample mean for a nominal column. There's no way to calculate that. So instead, it's given me different output. It's given me a frequency distribution chart, and it's given me frequency tables. So jump is paying attention to what our modeling types are to produce the output that makes sense. Now, in terms of it being a progressive interface and these red triangles, the red triangles are a really important aspect of jump. So whenever you're first starting to learn jump, definitely click on every single one of these. These are the seat of the progressive interface. These let you dig deeper, but they let you dig deeper in a particular way, a way that makes sense for the column you're working for, which is a really handy thing about learning statistics with jump because it sort of helps you know what makes sense. So for instance, let me give you an example. Let me click on the red triangle next to tip amount. So think about the domain we're in. We're in a distribution platform, which is about single variable analyses, and we're using a continuous column. So the options that jump will display here are the ones that make sense at this time in our analysis. So this might be where we'll test a mean. So if we want to compare our observed mean against some we expect under the null hypothesis. If we want to get a normal quantile box plot, or a normal quantile plot, excuse me. So I can just produce that right in line. There's no going back to a previous menu. I can just keep producing new things. The nice thing is that these options all make sense for this variable. So fitting a continuous distribution, I'm not offered this when I have credit cards because it doesn't make sense to do that. Now let's actually look at the red triangle next to credit card because this is in the same general context. We're in a one variable platform, but we're using a nominal column. And so this is going to give us different options because different things make sense. So confidence intervals about our observed proportions or testing the proportions. So this would be a one sample goodness of fit test or getting a different representation of the data, a mosaic plot, another way of looking at this. Right, so jump is being sensitive to what your data represent so it can give you the options that make sense. And I'll just mention that these are suggestions by jump. So if we change the modeling type for tip amount, let me change it to nominal. So this is me telling jump that I want to treat every unique observation in this column as a different category. I can tell jump that I want to do that, and jump will adhere to it willingly. So if I put tip amount back in my Y, it's got a different modeling type now. Jump will give me a very different type of output because jump is not enforcing me to treat those as numbers. It'll treat them as categories if I want, and I'll get my frequency table and I'll get my output. Right? This is a kind of a silly way to look at these data, but there may be times that you know better than jump because you're the one doing the analysis. Jump is just here to help you with that. So let me set this back to be continuous. So that's the progressive interface and the mind of jump really organized around the process. So as you produce analyses, you can keep digging deeper and the options unfold in front of you. Now, I'll point out that there is a potential downside of this progressive interface, the fact that options unfold as you get further and further into your analysis. And that is, if you're looking for one particular thing, you really want to do a particular outlier procedure, like a Mahalanobis distance, you may not know where to find that when you're first using jump. And that's where the statistics index comes in. And so I want to point you to this, and this is great if you're just learning jump. It's under the help menu, and there's the option for the statistics index. And what this will do is give you a list of those thousands and thousands of procedures that jump can do. And you can just click in here and start typing. I'll start typing Mahalanobis. And here I get the definition of it. It tells me what it's doing. It's a distance in multivariate space from the multivariate mean with respect to the covariance structure. I can click on the topic help if I want to learn more about that before I run the procedure. Or, and this is pretty neat, I can click launch. And what jump will do is bring up the platform in which that analysis lives. Notice that jump doesn't have it in a top-level menu. Remember, that only makes sense to produce if we're looking at multivariate data. So let me actually give it some multivariate data. I'll give it bill amount, and tip percentage. And what jump will do is pre-populate the output with the procedure I just selected. And this is where I could go ahead and, select the points that I think are outlying. I can maybe give them a different marker so I can, look for them in different outputs. It produces the output for me though, so I know where to find it. And this is where you would then look under a red triangle and you would see the section, outlier analysis. That's where it lives. So Jump Statistics Index is a great way when you're first learning Jump to find all those places in which your analyses live. Now, once you've used Jump as long as I have, or even not as long as I have, you start to know how Jump thinks about things. And so it'll start to be very obvious where options will live. And that's why I say click on those red triangles. You'll be surprised that you'll find all the things you're looking for. All right, so that's just the basic mind of Jump. Now some important features, some things that if you haven't used Jump before, I definitely want you to know, and some things that if you have used Jump, I certainly want to make sure you're aware of now. So column and row states. Now I want to point this out in the data set. If we are doing an analysis, and let's say we know that these first 5 rows are bad data. Maybe this was during our soft opening with the restaurant, and we don't really want to use those for any analyses going forward. Now you can select the rows in your data set, simply right-click, and we can do hide and exclude. Now what hide and exclude will do, and you'll see what happens when I select it, we'll get a little cross and then the little blindfold. So these data points, these rows, will not be entered into any calculations. That's what excluding data means. And they won't be shown in any graphics. That's what hiding data means. So if I were to go back to distribution and I were to put in any of my columns and click OK, the output I have now doesn't include those rows I've excluded. And so this is a great way. Certainly never delete data from your data set. Just use hide and exclude if you need to, remove certain rows from data. So to bring them back, I'll simply right-click on them again and select hide and exclude. You may have noticed that you can do these actions independently if you only want to exclude observations from calculations, but you don't want to hide them from visualizations. You can do that. And it may seem odd that you would ever want to do these separately, but sometimes if you're excluding an outlier, you still want to show it in the output, probably with a marker, so that you can show people that there is an outlier, but you don't want your regression line to be fit with those outliers. So excluding data without hiding it is sometimes important. Now, hiding data without excluding it, I've found less often that I use that, but there are times that you can probably think of where maybe that's worthwhile. All right, so that's column and row states. Now, something that works with those, that can apply column and row states for you, is the data filter. Sometimes we don't want to consider just the first 5 rows to be excluded. Maybe we want to exclude a particular server from our analysis. Maybe server C, for some reason, we don't want to include in our calculations. So the data filter, which is under the rows menu, is a great way to filter your data that is filtered before it gets into your analysis. So I'm going to select this, and let me show you how the data filter works. So the data filter brings up a little panel, and in the panel, we can pick which column we want to use to filter on. That is, which one defines categories or groups that we want to exclude or retain. So I'm going to click on Server and select Add. And what I get is a little panel here that lets me designate which groups I want to select. So let me select A and B. So hold down Shift and select both of those. Notice what Jump does immediately is selects them in the dataset. It hasn't hidden them and it hasn't excluded them, because to exclude and to hide, I need to tell Jump that's what I want it to do. So right now I have the checkbox for select, so Jump is selecting the observations. Let me check show and include, and notice that Jump is only showing and including the servers I've clicked. And I can click different ones, so I can show and include only B, show and include only A, or I'll hold down Shift and select both of these, so I'm showing and including only A and B. And so now, if I were to go to distribution, let me put in tip amount again. Now the output I'm looking at is only of A and B for the server. And so I can filter my data very quickly by doing this and click through. Now I want to show you one other version of the data filter. Let me actually clear my row states. Notice I have some things shown and include, so let me just do clear row states. Now there's another version of a data filter, and let me pull up distribution to show this to you. So I'll put tip amount in the Y. In every platform output you get, there's actually a version of the data filter that lives inside the platform itself. So sometimes you have multiple outputs. You don't want to filter your data table. You want to filter locally. That is, you want to filter just inside of this platform. And to do that, go to that topmost red triangle, go under Script. Script is where you have options for saving the script of this analysis. Jump has a very full-featured scripting language. But what I want to point you to now is the local data filter. This is the data filter that lives and actions on just this platform. So if I select this, let me do the same thing. I'll click on Server, and notice what happens now. If I click on Server A, my distribution output updates immediately. So I can click through the different servers. Maybe I want to look at just A and B. I'll select both of those. So this is a way to operate on just the output of this platform. Notice that it's not doing anything with my data table as I click through. But this is a great way for exploring your data, for learning about sort of the distributions of these different servers without having to reproduce analyses. All right, so that's the filtering options in JMP. Now, there's another way to get separate output for different groups. And I always like to point this out because it's an operation that you can perform with any platform in JMP. And that's using a by variable. And let me show you how this is going to work. Let me pull up distribution again. And you'll notice that there's a section at the bottom for by. What by says is whatever I set up on the top, I want JMP to split it up based on the groups or levels of the variables I put into here. So for instance, what if I put tip amount on my y, and then I put server as the by variable? And so again, in JMP's head, this is saying, take tip amount, that column, give me distribution output, but I want it separately for server A, B, and C. So let me click OK, and I want you to see what JMP's going to do. And I'm going to do one more thing here. You may have noticed that we have vertical histograms, which is a great thing for most screens. You usually have screens that are wider than you have tall. But I'm going to go to the topmost red triangle and select stack. So if you really like your distributions to be on their side, click that option and notice that JMP rotates them all for you. Now, with our distribution for server A, notice that this is the output just for server A. By using the by variable, JMP has split up the output based on the levels of that server variable. And so this is a great way to produce all of those outputs all at once. And so by is a section in every platform that you're going to use. And so if you need to split up analyses, maybe we have 10,000 servers and we want histograms for each of them, we can do that in just one click. Just stick server as your by variable, and you now have 10,000 histogram outputs with quantiles and summary statistics. Now I want to point out while I'm in here, there's this broadcasting commands option. I want to tell you the sort of reason why you'd want to think about this. Imagine I wanted to get normal quantile plots for each of these different outputs. For whatever reason, we're assessing the normality of tip amounts. And so you might imagine we have to go to the red triangle for each of these, turn on a normal quantile plot for the first, then go down to the second and do the same thing. So actually, that would take a long time, especially if we did have 10,000 servers. And so there's a faster way to do this in JMP, and this applies all over JMP. If you're in a platform like this, where you have multiple outputs that can accept the same command, there's a trick, which is to hold down Command if you're on the Mac. It's going to be Control if you're on the PC. So while I'm holding it down, I'm going to go select normal quantile plot. And what JMP interprets that to be is I want to broadcast the command to every output that can accept it. And so very quickly, I can make changes to one of these and have it populate the other ones at the same time. Now this works in multiple ways. Let me hold down Command, and I'm going to resize this normal quantile plot. So I'm going to resize it to be smaller. And because I'm holding down Command, JMP will broadcast the resize. What about these gray triangles? Notice that these gray triangles hide output or show output. If I hold down Command and click one of them, it'll hide all the quantiles, or it'll hide all the summary statistics. So the command trick, and again, it's Control if you're on the PC, broadcasting is very useful, especially when you're using by variables or when you're using platforms with many different variables specified. So if we use distribution with 100 columns, we could also broadcast commands to any output that can receive it. All right, so that's broadcasting commands. Now the final thing I want to show you is column recode. And I actually have a data table just like the one I was using here, but one where I've purposefully made some mistakes in data entry. And I want to show you what these mistakes are. Let me take credit card and server. I want to look at those columns. Let me actually go to distribution. And distribution is what I run every time I get a new data set. I usually give it all of my columns because it's a great way to screen your data for errors that people have made. So here's a situation where maybe we had different people entering in our data. And so for some of the yeses, people spelled it out or put a Y, and some of the no's, the same thing. And then for server, it looks like people came up with several different ways to enter the data wrong. So some people did uppercase C, some people did lowercase, some people put in server as well instead of the name, and even some did uppercase and lowercase when they spelled out server. So this would be bad. Of course, we don't want different versions of the same category because those will be treated as different things. In JMP's mind, these are all different categories, which is why they have separate levels. So a quick way to fix this, and I want to show you this utility. So let me do it with server first. It's under the columns menu, and it's called Recode. And Recode is a huge time saver because what Recode lets you do is designate the new levels or the new values for your old values. So for instance, if we wanted all of our letters to be uppercase, let me just say for the lowercase a here, that should be uppercase. For this one, it should be uppercase B. This one should be uppercase C. And we don't want any of these with servers. We just want anything that said server A before to also be an uppercase A. Anything that said server B before is also an uppercase B. And anything that said server C before is an uppercase C. So I've just defined the new values, and I'm going to click OK. And now JMP has recoded that entire column. So if I go back to distribution, notice that I have the levels back where I wanted them, the correct way of entering them. Now I want to show you something else. Notice that when I recoded in the way I just did, it recoded into the column that I was using. Now, that's actually not my recommendation. I would almost always recommend you recode into a new column. So let me show you that with credit card, because notice credit card has another issue we should fix. So I'm going to go back to columns, go back to recode. Let's do the same thing. I just want N's and I want Y's. So this no should be recoded as an N, and the yes should be recoded as a Y. All right, so instead of selecting in place, we have some other options. Now my favorite is actually a formula column. Now let me show you the difference here. A formula column and new column, both of these will produce a new column either way. What a formula column does, however, and this is really neat, let me click OK, we get a new column in our data set. It looks like it's just recoded the values, and it has, but it's accomplishing it not by writing the values, but by applying a column formula. So let me show you that. I'll right-click the column, and notice that formula has a checkbox. Let me click on that. What JMP wrote for us is a match function. It is dynamically recoding the original column, which means if I have new data entered, and people continue to enter things ridiculously or change the way they enter them, my credit card 2 column, the one I just wrote, will continue to recode. So no matter how many data points get entered, JMP will continue to recode those data into the proper values. And so the formula editor here, and I won't talk about it too much in this webinar, but the formula editor is really rich. So this is just using a conditional function. Under conditional, match basically says, look to this column, credit card, and if you find the value of no, enter in this new column in credit card 2, the value of N. And if you find a yes, enter in the value of Y. Otherwise, if you don't find either of those two values, just write the original value, which is to say, if people entered it correctly to begin with, just enter the original correct statement. And this is actually written in JSL. If you double click inside the formula, you can see the underlying script that this is using. And so the formula editor is powerful for point and click formula creation, but the underlying scripting language, which is beyond the scope of this webinar, lets you do some very incredibly powerful things just inside of a formula column. And so that's a great feature of JMP, especially when you're recoding. So again, that's just under the columns menu under Recode. All right, so I want to pause here and actually see if Walter, we've gotten any questions. I think I went through a decent amount of stuff right then, but I certainly want to pause and see if there's any questions about this topic before I move on to summarizing. Mm-hmm. The dates to a decimal years. You mean, I don't have any dates in this one. You can. Let me hold off on that until the end. But yes, there are some date functions that we can use in JMP. In essence, you can, it won't work for this column, but when you actually go into the formatting, there's actually dates that you can specify what format it's in. And then using a column format, we can actually recode them into new dates. And that's actually, I may have a data set in just a minute that will have some dates in it. I'll actually show you that using one of JMP's automated recalculations. So if I don't come back to that by the end, definitely make sure Walter asks me again. Mm-hmm. Okay, great. Well, hopefully, I think I will have a data set with some dates in just a minute. So we'll play with that. Okay, so let me move on to summarizing data because I'm excited to show you Tabulate. So we'll stick with this data set for a second, and then I'll play with US demographics, which has some richer data. But Tabulate is drag and drop table creation, and it's built around drop zones. And so let me show you how to get to it first, and then I want to show you how it works and some of the drop zones it uses. So Tabulate's under the Analyze platform, or Analyze menu. So it's Tabulate right there. Now I'll mention if you're using JMP 10 or an earlier version of JMP, Tabulate used to live under the Tables menu. It really is a table creation tool, but it's so great for these simple analyses where all you really want are a table from your analysis. And so here's the basic outline of Tabulate. So it's giving you a little grid here. These are the drop zones that it can accept columns in. And I want to show you how this works. I mean, I want to imagine we have a situation with this data set where maybe we want to know the total amount of tips that each of our servers made this week. So we can imagine the table we want. And so server here, I would probably want to have server as rows. So I want for each of my servers a row. And what I want to have at the end is the sum of the bill amounts or tip amounts. So let me try this. I'll just drag server to the drop zone for rows. Notice it highlights. And that's important. You'll see that jump will highlight the drop zones you're using. So I'm going to drop it there. Now the first thing that jump gives me is the number of individuals because I haven't selected any other variable. So what I'm going to do is I'm going to take tip amount and I'm going to drag that right inside here, the drop zone for the resulting cells. And I want you to see what jump does. It immediately picks a summary statistic. The easiest one is a sum. That's actually what I wanted, but it's giving me this sum for each of the servers of their tip amounts. And so I've just made a very simple table. This is, of course, very simple. But before we go on, I want you to notice that even though it's in this little Tabulate platform, I can click Done, and we have a nice little table. We can also, by clicking this red triangle, make this into a proper data table. Maybe these are data you want to continue to analyze. So if you do this, Jump will convert it to a proper data table, not just a little table in a window. So we're not going to use that one yet. Let's go back and play around with this more. I'll go to the red triangle and show the control panel again. So let's actually make a little bit more complicated of a table. Maybe we don't want just the tip amounts for each server. We want to know the sum of the bill amounts as well. So we don't have to limit ourselves with just one variable. Let's grab bill amount. And I want you to see this. So if I hover over the drop zone here, notice that it's highlighting tip amount. Now in Jump's mind, if you highlight an entire section, that means you want to replace that variable. Let me show you what I mean. If I drop it here, notice that Jump replaced tip amount with bill amount. That's actually not what I wanted. Let me click undo. Let me take bill amount, and I want to show you a drop zone you may not have seen. So here's the hover one. In Jump's mind, again, that means replace. There's a drop zone right to the right and right to the left. Oops, that one right there. So those two drop zones, those are append and prepending drop zones. So if I drop it on the one just to the right, notice that Jump appends this data table to have bill amount as well, and we have the sum. We can do this with our other variable. Maybe we want the sum of the number of guests they help. So we can drag that right there to the side as well. So we can create pretty sophisticated tables here just by dragging and dropping. If we want to get rid of a section, we can simply just drag it out. So we don't want tip amounts or bill amounts anymore. We just want one of these variables. Now we can also do things other than the sum, of course. Maybe we want the mean. So if I take the mean, I could just drag this right on top of sum. Remember, if you drop on top of something, that means you want to replace it. Let me click undo. And if I drag to the right or left, I also have those little drop zones. So maybe let me prepend it here. So I have the average tip amount and the total tips earned this period for each of the servers. So pretty neat. You can create your sophisticated tables without really much work at all. Now, we're not limited on the left-hand side with what we're doing as far as grouping either. So for instance, maybe we want to know by server, but we also want to split this up by day of week. So we want to know the average tip amount and the total made for each day of week for each server. Maybe this is how we're going to pay them out of the month. So let me grab day of week. And remember our rule. If I drop on top of server, that's going to replace it. But if I drag to the left or to the right, that'll prepend or append. Now, this is actually a choice for us. Let me put it on the right-hand side and notice that the nesting works like this. We have days of week nested inside of server. Maybe that's a way that we want to have the table, but we can do it the other way as well. Let me grab day of week, stick it on the other side. Maybe this is a more intuitive way for us to have it written out, especially if we're posting these or writing them out for each day. So depending on what makes sense for you, or depending on what is the most easy way of displaying the data, you have a choice. Now, I want to show you one more little trick here. So let me grab server. So remember, servers on the left as our rows. We're not limited to having it as rows. Maybe we want a data set like this. So I just dragged server right above. So now it's day of week. And then we have for each server, the tip amount, mean, and sum for each of the different servers separately. Notice we have some missing cells. That's because some of these servers weren't working certain days. So Jump knows that if you don't have any data, it's not going to calculate something. So JMP lets you make pretty sophisticated tables here just by dragging and dropping these variables around. And so I would definitely recommend getting used to using Tabulate when you want to make these simple tables or even complicated tables. It'll actually be a handy way to summarize your data, especially if that's your end goal. All right, so before I leave Tabulate, any questions on that you got, Walter? All right, cool. Okay, I'm going to close this guy then. Let me see if US demographics, I don't think I got any dates in this one either. Nope. Yes, I'll find one with a date for you. All right, so analyzing data. Now, we're not going to get through too sophisticated of analyses today, but I do want to show you some of them in JMP, especially fit Y by X. I'm going to still start with distribution because I didn't do any of the analyses that distribution can really do. I just sort of showed you the platform. So I want to start there, and I'll stick with this data set for a second, and then we'll actually move up to maybe a more complicated one. But if I do distribution, remember, all of our platforms in JMP are sensitive to the data types you have. And so let me pick two different ones. I'll use bill amount and I'll use credit cards. I'm going to click those both into Y, and I'm going to click OK. Now for bill amounts, we could, I'm not sure exactly what the impetus for here would be, but we could test this mean. So we have a mean of 22.72. Maybe we know historically the average bill amount in a restaurant has been $20, but perhaps we changed our menu around. We put pictures on it this week, or we're doing some kind of experiment to see if we can drive up the average bill amount. So if we wanted to test this mean, under the null hypothesis again, maybe it really is 20 for some reason. That's an historical average. Let's go to the red triangle, and I want to point out the test mean section. That's probably the most common thing we're going to do with a one sample continuous variable. And so I'm going to select test mean. And notice what JMP brings up is our little test mean panel. So we can enter the null hypothesis mean, so the mean we expected for some reason. I'll put in 20. If we knew a true standard deviation, we can get the z-test. This is such a rarity that we almost never do it, so I'll leave that blank. And if we'd like to do a non-parametric test, so this is the equivalent of that one sample t-test, but non-parametric, we can click this here. Let me actually do that, just so we get the output as well. So this is all we have to set up, and when I click OK, notice JMP will return that output right at the bottom. And let me actually just hide some of these extra sections so we can bring it up a little bit here. All right, so notice it gives us our hypothesized value. That's what we entered. The actual estimate, the mean that we actually observe, the degrees of freedom we have for this test for estimating the population variance from these data, and we actually have our standard deviation. And so JMP's going to return our t-test and our Wilcoxon signed rake right next to each other. And the sections are the test statistic, so our observed values of each of the test statistics. And I want to spend a second looking at the way we're writing out our p-values. So the two-tailed p-value is listed out the probability greater than the absolute value of t. So that's the proportion beyond our observed value of t in either direction from the null. And so we get our actual p-value here. And I want to point out that our diagram below, this is actually the sampling distribution of the mean under the null hypothesis. So this is the representation of that. So we entered 20 as the center of the sampling distribution of the mean under the null. Our observed value is out here. And so the shaded regions, which you may not be able to see too well, we actually have a very small p-value, but the sum of those two shaded regions on the right and left, well, that is the p-value. That is the two-tailed p-value. And then the probability greater than t, that's just the p-value in this tail. And the probability less than the observed value of t, well, that's everything to the left. That's actually not shaded here. But I make a point about this because I really love that this is an attribute of JMP to display a graphic with every statistic if possible. So every statistic you get is meant to show you something that represents it. And this is especially nice when teaching. So the class I'm teaching right now, I love to have my students do this. Go to the red triangle next to test mean and check out these options. There's one for a p-value animation. And so this is really fun for students. So they can move around what was predicted, essentially what under the null we expected. And they can get some insights into why the p-values are bigger or smaller. So if we expected under the null a value of 22, much closer to the observed estimate, well, of course, our p-value would be higher. Under the null hypothesis, it'd be more likely for us to obtain our obtained sample mean if we had hypothesized a mean closer to the one we actually got. And so the p-value animation is great. And I love that these are interactive and you can click low and high sides. They're also great just for, reminding yourself what these things are representing. At the same time, there's also one for power. So you can get a power animation. So especially nice for classes where you're really driving home what our probabilities are for false alarming and for missing. And so you can drag around sort of what we assume is true about the world and what we actually observed, and show actually that beta region and the power. So those are just little extra things underneath this test mean. And again, this is an attribute of JMP in general to give a graphic with any statistic. So that's for a continuous column. Let's see what option we have here for credit card. So typically, if we're using nominal categories and we only have one variable, well, that's a chi-squared goodness of fit. And so for testing those proportions, we have the option here. It's listed as test probabilities. And what this gives us is a little panel. So notice that it's showing the estimated probability. So that's the one we actually observed for no's and yeses. Suppose, again, under the null hypothesis, we had some expectation that half of our tables should use a credit card and half should not. So maybe this was, again, historical, what was going on. And after we changed our menu or maybe did something else, we want to see if we've observed a change in that, a statistically significant change. So we have a couple options down here. We can do this probabilities not equal to the hypothesized value. That's our standard two-sided chi-square. We can also do the exact one-sided binomials if we want to specify a direction here. So let me click Done. I'll just leave it on the default. And we get our likelihood ratio and our Pearson chi-square. So JMP reports the values again in line. That's sort of an attribute of JMP as well. There's no going back and selecting something earlier to produce an analysis. You just set it up right there. So that's really the two main things you'll probably be using distribution platform to test. There may be other times, especially when we're working with certain data sets, where you need to test whether something is a normal distribution, or whether, rather I should say, you believe your sample was drawn from a population that is normally distributed. So that's under a continuous option, so continuous fit here. And I showed this earlier on kind of quickly, but I want you to see that you can fit all sorts of distributions. So if you are just trying to find which of these distribution fits best, we can actually select all. And this is pretty neat. JMP will actually go through, give us all the distributions, and it'll give us the negative log likelihoods, the Yaki information criteria, and it'll actually select the distribution that best fits. And so the gamma distribution here is the one that's best fitting. And remember, whenever you get red triangles, especially when you're learning, I would certainly suggest you click on these and you see there's lots of other options. So once you fit the distribution, you can even get the Shapiro-Wilk, so the goodness of fit test. And like most things in JMP, or I guess it's going to be the Kramer-Nemes we have a gamma, but it's going to do our tests. And I would just point out that you can turn on, if you want to compare all these distributions, you can actually turn them right on here. So if your job involves fitting continuous distributions, the JMP fit distribution is really, really powerful for this. All right, so that's basically what we would do with distribution. Now I want to show you fit y by x, because fit y by x, which I haven't shown yet, is when you have situations where you're comparing two variables. So that's why it's a y, and that's why it's an x. So let me actually go ahead and launch this platform, and I want you to see sort of what this visual is showing. So this is a visualization of what JMP will produce when you give it variables of certain types. And so it's a little legend is what it is. So if our x variable is continuous and our y variable is continuous, what JMP is going to launch with this is a bivariate analysis output. So that kind of is the domain of regression and correlation. Now, if you have categorical on the x, so nominal or ordinal, and you have a continuous y, that's sort of the domain of one-way analyses. So this is ANOVA, t-test, even the non-parametric equivalence. A continuous fitting against, a y that is nominal fitted against a continuous, well, that's logistic. And then categorical against categorical, these are contingency. So let's try a couple of these. I'm going to start with something basic. So let's start with the one-way section. So here we're going to fit something categorical against something continuous. Let's see if we can predict tip percentage. So the percentage of a tip. Let's see if we can see if that changes whether somebody used a credit card or not. So this is going to be a two-level x variable. Let's put them both in, and you'll see that JMP right away said one way. So JMP knows what this analysis type is going to be. So let me click OK. Now JMP will give us a dot plot output. My suggestion for you, just because I don't like dots all on top of each other like this, you can't really see the spread very well. The first thing that I do, and actually I set this in my JMP preferences, is go to the red triangle, go to display option, and select points jittered. And so points jittered, which is under the display option, it'll span them out like this. So you can actually see the spread of data there. All right, so notice that JMP didn't produce any analysis yet. JMP is not enforcing you to run a t-test or to run an ANOVA or even the non-parametric. It's simply giving you the platform in which those options will live. And so look at the options under the red triangle here. So these are options that make sense given the fact that we're fitting continuous y with a categorical x. So we can get quantiles. If you would like box plots and a quantile report, I actually like to turn these on often. Gives you the nice little box plots there. You also get the means and ANOVA option. I'll run that in just a second, but let's step through some of these other ones. Just want means and standard deviations. You can get them here. A t-test, not assuming equal variances, which in our particular situation right now might be worthwhile. The variances don't look the same. Compare means I'll come back to in a second. When we have a number of levels on our x variable, it'll be useful sometimes to run each pair. So compare each against each other. What I always tell my class is, especially when you're just exploring data, you should probably using a procedure like Tukey HSD, which is going to correct for multiple comparisons. That'll actually apply a multiple comparison correction, so you won't false alarm more often than you should. And we have a couple other options here that are going to apply multiple comparison corrections. Non-parametric options live right here as well. So very close to where you would run a t-test, you can run the equivalent of a t-test. So you can run the Wilcoxon, so a non-parametric version. And I just want to point out, if you have, again, multiple levels on your x variable and you want to run non-parametric multiple comparisons, I really recommend this Steele-Dwas. So this is just like a Tukey HSD, alpha controlled. So you can explore your data without worrying that you're inflating your family-wise error rate considerably. So the Steele-Dwas is a really cool procedure. What I love about this, though, is that notice in the platform we're in, JMP knows what analyses are possible or what makes sense. And so I'll even tell you, I learned about the Steele-Dwas because I was exploring the menus in JMP one time. And I wondered to myself, oh, what is that non-parametric multiple comparison procedure? And so JMP taught me, because of the way it works, a new procedure. And so I always love this about JMP, and I find my students learning a lot of new things because of this too. Now, as we go down the menus, I'll just point out a couple more things. The unequal variances test. So this is something I would certainly suggest running in situations where you can see that there's a huge difference in the spread here. And so we get a number of different tests. So the F-sided 2 test, or F-test 2-sided, Levine's test, to compare whether we believe in the population these variances are the same. Certainly, if we violate that assumption, that may change the types of analyses we decide to use. And I'll just point out some other ones. Robust fits, so applies Huber functions to fit these means robustly. Equivalence tests, if your interest is not in telling whether something is different, but whether they're less different than some practically significant amount. So an equivalence test is a really cool way of not proving the null, which you can't really do epistemically even, but a way of showing that the null hypothesis within a particular range is pretty reasonable. And you can do power analyses, alpha level changes, all of these right in the platform. All right, so that was when we set up our analysis in fit y by x with one categorical x and a continuous y. Now I'm going to keep this open because what I want to show you is how JMP is contextualizing the output. Let me go back to fit y by x. Instead of predicting tip percentage on the basis of something categorical, let's try it on something continuous. That's going to be the bivariate domain. And so let's do tip percentage on the basis of bill amount. Now notice that tip percentages, in essence, this has been scaled, but maybe there's some reason for us to think that when people are spending a lot of money, they'll actually tip a higher percentage. Of course, we should expect them to tip a higher amount, right? That's why percentages typically stay about the same, but maybe we think there's some other relationship here. So let me click OK. JMP will give us, just like it did for our OneWay, it starts us off with just the representation visually. And we can see some points here. I would actually be maybe a little, concerned. These are huge tips here, 40% and 45%. You'll notice that when I select points anywhere in JMP, it selects them in the data table too. So actually, I'm gonna right click on these guys and put a marker on them. I might wonder about them later on. But just to start, I want you to look at the visual and notice that we didn't get any output. No regression was fit for us. JMP is not enforcing that. But under the red triangle, notice the options are considerably different from what we got in the other analysis. Even though we use the same platform, fit y by x, JMP knows that different things make sense now. Of course, because we're having one continuous variable fit against another continuous. So perhaps the simplest thing we might want to do, fit a line. So I'll fit this here. This does our basic linear regression, and we get the output you should probably expect, a summary of fit table, a lack of fit table because we actually have near replicates here, so we can actually perform a test to see if we're missing variables and explaining the relationship. Basic ANOVA table and parameter estimates. I'll point out that, and this happens a lot, whenever you produce an analysis, you're often given another red triangle. And remember, those red triangles let you dig further. And so I always point this out because once you've run a linear regression, well, that's probably the time you'd want to now look at the diagnostic plots. Maybe you should look at your residuals, make sure things are well behaved. And so that option will live under that new red triangle. This is where, and I make my class do this anytime they run a regression, plot those residuals immediately. So they produce the residual output so they get some diagnostic plots. Residuals by predicted. How well behaved is our model? Residual by row. Do we have serial correlations that we have to worry about? Residual by X, or even the residual normal quantile plot. Do we think our residuals are actually normally distributed? So I point that out only because when you produce new analyses, look for new red triangles, because you'll find that there are additional options that you'll almost always want. So one that I really like is putting on the confidence intervals. So I like to shade that for the line, the working hoteling confidence band. And often, at least personally, when I do analyses, I almost always save my residuals. I like to save those to the data table. So if you do this, you'll actually get a brand new column in your data set that gives you the residuals for that model. And I like to do this just because I like to, do additional diagnostics personally on my residuals. But so notice that, and this is the main point of what I'm showing here, is the options that fit y by x shows you will depend on what your variables are when you set it up. So things like non-parametric densities, right? If you're thinking about the density in two-dimensional space, that wouldn't make sense to show you if you're considering a situation where you have a categorical x. So again, JMP contextualizes what it shows you as a way to make sure you're not fitting things that are wrong, but to make it easier for the menus, because you can click through and find things a lot quicker when it's only showing you the things that are relevant. So I think that's a pretty powerful advantage of JMP. All right, so we have 2 of the possible 4 combinations here. So remember, let me launch fit y by x again. We've done bivariate and we've done one way. Let's see what a contingency analysis looks like, because I want to actually show you how JMP's going to represent the contingencies. So let's try something like this. Maybe we're wondering whether people choose to use a credit card or not based on server. Maybe certain servers, based on certain actions they have, evince people to use a credit card. I'm not sure what that would be, but this is at least a situation where we have one categorical against another categorical. So it's not going to be a scatter plot type representation. It's not going to be our one-way representation. Instead, what we get is what's called the mosaic plot. And mosaic plots, I think, are so neat. And I remember when I first started using JMP in 2005, I had never seen a mosaic plot before. And I just love them now. So what this is showing is the proportionality of both variables at the margins. So the proportionality of servers, how often was server A, B, and C in the data set. It's showing us the proportionality of use of credit card, yes and no, at the margin. And it's also showing us the contingent proportionality. To what degree are individuals using credit cards for server A, B, and C? So starting just at the margin for credit card use, that's actually what this band is showing us here. Let me actually drag it out to make it a little more clear. So the yes is up here. That proportion, I'll just hover and notice that JMP was going to show it to me, 32.5%. Said yes that they use a credit card or did use a credit card. And overall, ignoring server, this other bar, right, that's the proportionality of not using a credit card, 67.5%. So we have a representation at the margin here of credit card use. That one's pretty obvious. For server, it's probably a little less obvious, but look at the spacing on the x-axis. The spacing for A and the spacing for B is wider than C. C was actually less represented in the data table. Server C worked fewer days. So the spacing of the x-axis here is representing that marginal proportionality. And then the magic happens in the middle. What the chi-square test of independence is paying attention to, what any analysis that's based on contingency data is paying attention to what degree is the proportionality of yeses and nos the same for server A, B, and C. So to the degree that these interior portions are not homogeneous is evidence against the idea that the two variables are independent. And notice that server B here, server B had, yes, more no's to the credit card than server A and C. But if we look down at our tests, 0.05 for, okay, so we're getting close. I wouldn't consider this very strong evidence that there's some true difference between servers and how much they get people to use credit cards. but certainly you can see that there is a numeric difference in the proportionality. So that's the mosaic plot, which is a really neat way of representing these data. And I'll just show you under the red triangle, like I've shown before, the types of options to dig deeper will change because different things make sense when we have two categorical variables. Right? This is where we can perform exact tests, analysis of means for proportions, a funny name for a really cool procedure, correspondence analysis, and all of our measures of association. So if you need effect sizes essentially for these, it'll print out a whole big table of measures of association that you can report for these data. And so that's the mosaic plot, a really neat way of representing the data. And that's the contingency platform. Again, one of the 4 that we can do just with FitY by X. It's probably the second most simple analysis platform in JMP, but incredibly powerful and fast. Now, I just want to show you one final thing here. I know I'm running close on time, but the platform, even though I was doing these one at a time, notice I produce all separate analyses, there's no reason you have to do that. I could actually get all of these analyses at once. In fact, if I put tip percentage as the Y, let's look at tip percentage on the basis of bill amount. I did that one. I also want to look at tip percentage on the basis of credit card use. Maybe I also want to do it on the basis of server. Maybe different servers have different tip percentages. So I have many analyses here. It may look like this is going to do some sort of ANOVA or something that's controlling for bill amount, but JMP will actually, in FitY by X, fit these all separately. So what we get are 3 separate outputs in one window. And remember the trick I told you? If I hold down the Command key, click on a red triangle, 2 of these can accept a means ANOVA pooled T option. So I'm holding down Command. It'll be Control if you're on the PC, but I've now just produced 2 ANOVAs, and I'll go over here and produce a linear regression. So in one window, I can look at tip percentage as a function of all these different outputs or all these different variables. And I'm not limited to 3, of course. I could have 10,000 X variables if I want, and I could produce 10,000 ANOVAs at the same time if I wanted. Now, I'll point out one final thing, which is we have a summary of fit table for each of these different outputs. And maybe you want to get those all to a new table. And this is the final little trick I'll show you. If you right-click on a table in JMP, you can do 2 things. You can make it into a data table on its own. That'll take what's in there and drop it into a table. Or, and you probably saw the option, if I right-click it and select Make Combine Data Table, JMP will pull together all of those tables from the analyses I just had. And notice what I have here. When I'm predicting tip percentage on the basis of bill amount, credit card, or server, I have the R squared, the adjusted R squared, all the attributes of the table right there. And let's say I just wanted to keep one of them, just the R squared. So we can, remove the rows associated with the other ones if we like. And it'd be as simple as just, selecting them and deleting the others. So maybe we just want a combined table with just the R squares. So if we're looking through a lot of variables to see what predicts something the best, JMP makes it incredibly fast to do that. So again, take advantage of the fact that in FitY by X, when you're setting up your analyses, you can do it just all at once. You don't have to run these all separately. All right, so I'll stop there. If there's any other questions, I certainly want to address them. I know I'm right up against the final time. I'll again point out the learning library and the JMP user community. So certainly check those out and check out more of our webinars too if you certainly like what you see here and want to see more. So I'll pause for questions now.